Hey there, this is Horner, and we're going to look at exercise number 1 for equilibrium. While moving out of our dorm room, you have a lady named Bridget, and so we're going to draw our dot for our free body diagram. And she's carrying some pizza, and she's holding it with both arms. They want to know how much force is exerted by each of her arms in order to support that box. So we can draw a line straight down. Remember, that line is always going to be the force of gravity. And then she has two arms, so we're going to draw two force of tension lines, and they will both point straight up. So this is Ft, and then on the other side you also have Ft. At this point we know that Fg is equal to 120 newtons, and they want us to find out how much force is exerted by each one of her arms. The sum of the forces then will only have the y direction because it's not accelerating, it's equal to 0 newtons. And now we need to look at everything in the positive direction. So we're going to say that this is the positive y, and going to the right is the positive x. The sum of the forces in the y, we have two forces of tension, so we're going to put 2 Ft. And on the other side we have Fg, so we're going to subtract Fg, and that should be equal to 0. So now we'll move the Fg to the other side, so 2 times the force of tension should be equal to the force of gravity. And so now our force of tension is just equal to the force of gravity divided by 2. Force of gravity here we know is 120 newtons, and we will divide that by 2, and we end up with 60 newtons in each one of her arms. For letter B, they want to know if she shifts everything to just one arm, how much force would there be? And now our diagram would go back to just one force going up and one force going down, and at that point, since they're not moving, the sum of the forces would be 0, and that would just be Ft is equal to Fg, and so it would be the whole 120 newtons. And that is how you do equilibrium exercise number 1. Let's go ahead and look at equilibrium exercise number 2. In this one we have a flower pot. And because we have a flower pot that's hung by 3 different strings, let's go ahead and draw that. So here's our flower pot. We have 3 strings, 1, 2, and then we've got 3, and then here's the rest of the flower pot. And what they also tell us is that there's an angle right here of 15, oops, got to get the 0 on here, 15 degrees. And that's this angle right here. So we've got our flower pot, we have our angle of 15 degrees. They want to know what is the tension in each rope. So we're going to do this for one of the ropes, and then we'll be able to figure out kind of what it is for all 3 then, for each one of them. So let's go ahead and draw our dot diagram. Here's our dot diagram. We know that pointing straight down is the force of gravity. So we're going to go ahead and do Fg here. And they tell us that the flower pot is 42 newtons. Now we're only going to draw one of the lines. Let's just draw the one that's right here, okay? And when we do that, we know that this line is going to be a reference line of 15 degrees. And we want to find out what is the force of tension in that line. So in order to do this, what we need to really look at then is, let's look at the side that would be on our axis. So we know we have plus y going up. We know that to the right we have plus x. And we need to go through and figure kind of out what's going on. There are 3 of these, so I'm actually going to call this 3 times Ft. And they all make an angle of 15, and they're equally spaced, so we don't worry about this direction at all, okay? So there's no force that we're going to worry about going to the right. We're only worried about the force going up. All 3 of the forces going to the right, and then you'd have one kind of going to the left and one kind of going back. Those will cancel. So we're only worried about the forces that add, and that'll be the force going up. So let's go ahead and look at this. We know that this is the hypotenuse, so this will be Ft times the cosine of 15, and we said that we have 3 of them, so we're actually going to make it 3 times Ft times the cosine of 15. So the sum of the forces in the y, because this is an equilibrium, it's not moving, and it's not accelerating. If it was moving, it just couldn't be moving at an acceleration, is 0. Going up, we have 3 times Ft times the cosine of 15, and then we subtract off of that Fg, and that gives us 0. So now we can say 3 times Ft times the cosine of 15 is equal to Fg. They told us in this that Fg is 42 newtons. So we have 3 times Ft times the cosine of 15. And we need to get the Ft all by itself. So we're going to divide both sides by 3 and by the cosine of 15. So Ft here is going to be 42 over 3 times the cosine of 15. So now at this point we need to go ahead and figure out kind of what's going on with the rest of it. If we take 42 and we divide it by 3 times the cosine of 15, we should end up with somewhere around 14.5 newtons, and that would be the tension in each one of the strands. So not all 3 of them together, but each one of the strands is going to be 14.5 newtons. So that's number 2. Let's go ahead and take a look at number 3. And number 3, we have Luke Skywalker. He is going to swing Princess Leia across a chasm. And so what I'd like to do is I'm going to take a picture here, and I will actually put the picture on the screen. So there's our picture of Princess Leia and Luke Skywalker. I know it's not the best picture in the world. We'll make it a little bit smaller so maybe you can see it better. But they're going to swing. So let's go ahead and set this scenario up where we've got Luke, here's our rope, and he's going to swing woo, all the way over to the other side, and then they're going to get to safety. They would like to know when they start to swing and they have a angle here of 30 degrees with the vertical. So this is 30 degrees here, and it's with this vertical line. Remember, vertical lines go up and down. They would like to know what is the tension in the rope just before they start their swing. So here's where they are. And one of the things we need to find out is what is their combined weight. And their combined weight is 1,450 newtons. So that would be our force of gravity for the two. And that's if it's going straight down. So we know that straight down is the force of gravity. We know that coming back this way is our force of tension. So this is Ft. And then we could draw another line here, and that would just be another side of our triangle. So here's our 30 degrees. At this point, we need to figure out what is this force of tension. So we've got this side of the triangle, which is 1,450 newtons, and we're looking for this side of the triangle. So really, this one's pretty easy. All we do is we just need to find the adjacent side. So to solve this one, we're going to say the force of tension is equal to the opposite side, which is 1450, divided by the cosine of 30 degrees. Oops, better make it better 30. That equation just comes from force of tension is equal to the force of gravity divided by the cosine of 30. Because we're looking at, this is the adjacent side, and this is our, oops, sorry, this is not the adjacent side. This is the hypotenuse. That's my fault. And then this is the adjacent side. Alrighty, if you go ahead and solve that, you'll find out that the force of tension then is just equal to 1,670 newtons. And that'll be the end of this video. We'll go ahead and do another video for problems number 4 and problems number 5. And then finally B3.